Hello everyone. So my name is Orkodip Mandal from NIT Kurukshetra third year computer engineering. So now I will be participating in Codeforces round 764 div 3 which as you can see will be going to start in about less than a minute. So let's see how it goes. I will screencast my participation throughout the whole contest, and let's see how it goes. Wish me good luck. Now 40 seconds to go. 20 seconds remaining. Lot of writers for this problem, sorry, for this contest. 10 seconds to go. Let's see how it goes. 5 seconds, 1 second. Let's go. Contest starts. No, our sublime is working fine, I think. Yep. So here goes the first problem. An array of integers and yanks perform certain perhaps all in the same. In the same factor. And this one is by 1. Okay. So I think all elements should be equal to the maximum element. 1, 2. Okay. Okay, so I think the answer should be just the maximum element. Okay. Let's check on the sample test cases. 3, 4, 1 should be output. Okay, no, this is bad. Like all the elements they are equal. 3, 4, 1, 8, 6, 1. Okay. Okay, so everything has been made to 4, 4. So one operation here, in one operation, you can take some indices of the array. Okay, got it. So, okay. So I think it should be the maximum of this. So max of answer comma maximum minus x. This should be it. 3, 4, 1. Control C. Submit code. I think this should be okay. Happy New Year. Cool. Standings. How my friends are performing. Priyan's is performing very cool. Problems. Cool. Okay, so now here goes the second problem. This problem B. Make a P. Got in 3 integers A, B and C. Let's see how the problem here goes. Polycarbonate 3% he can perform the following operation exactly once. Choose a positive integer m and multiply exactly one of the integers a, b or c by m. Can polycarb make it so that after performing the operation the sequence of numbers abc in this order forms an ap? Note that you cannot change the order of a, b, c. Okay, so here is given the definition of AP. So and multiply exactly one of the integers a, b or c by m to make a, b exactly. Okay, so to make exactly arithmetic progression. So in this case I can make it yes in this. Okay, so I think that's easy. So let's just take the input first. answer equal to 0, if answer, that is if we can make, we should output yes, else we should output no, and now we make yes for L equal to 0, I was 3 plus plus for L j equal to I plus 1 j less than 3 comma j plus plus. Okay. Now if I equal to 1 and then j equal to 2. Okay, so now okay, if I not equal to 1 and then j not equal to 1, this means that thus I can make changes to the second element. Else if I not equal to 0, this is I and then j, this means I can make changes to the first element. Else if I not equal to 1 and then j not equal to 1, I can make changes to the second element. Else I can make changes to the third element. Okay, so now if I can make changes to the second element, okay, so I can make changes to the first element here. So element d equals to a of j minus a of I. Okay, element required equals to a of I minus d. If required, okay, if required percentage, if required percentage a of 0, then this is not possible. If required by a of 0, if required less than 0, if required by a of 0 is less than 0, then also continue. Else answer equal to 1. Okay, so else I think okay. I think just copy these things. Control C, Control V, and in this case d should be equal to a of j minus a of I by 2. Let d equals to f j minus a of I. If d and 1, then in this case continue d slash equal to 2. Required equals to a of I plus d. If required percentage a of 1, continue. If required a of 2 less than 0, continue. Sorry, it should be positive integer. Okay, less than equal to less than equal to. So continue, answer equal to 1, break. Okay, and I can just check if answer break, and else I have to do this thing. I can change the second, I can change the third element. D equals to f0 minus f1. This thing should not be there. A of I, a of j plus d. If required percent a of 2, continue. F plus answer equal to 1, break if answer break. Okay, so this is it, I think. Yes, lot of spaces. Let's check this code. Yes, no, yes, no, yes, no, yes. Yes, no, yes, no, yes, no, yes. This is cool. Submit my code. Control B, Control V, submit. This should work. Okay, cool. 10 times. Premise 10 links. Okay, so I have solved problem B pretty fast. That's great. Let's see my solution to problems A and B once. Yep, this one was easy. This one was also easy, and I have done all the things correctly, right? Let's check it once again. It may fail in the, let's check this once again. fj plus t, it's cool. Let's move on to problem C now. Okay, you are given an array consisting of n positive integers you can perform operations on it. In one operation you can replace any element of the array ai with ai by 2, uh, that is ai floor 2, that is by an integer part of dividing ai by 2 rounding down equal. See if you can apply the operation sum number of times possible 0 to make the array become a permutation of numbers from 1 to n, that is so that it contains all numbers from 1 to n each exactly once. Cool. How many submissions for this problem? 48. Let's try this. I think only yes no I have to print. Yep. So how to approach this problem? Okay, first let's take the input. I think 45 factor of LL of n plus 1 equals to 1 I less than plus f I. Now I have to make it a permutation of numbers from 1 to n, and okay, so since n is less, since n is less, one second just, okay, since n is less, 1 can be achieved from anything, 2 can be achieved. Okay, so I think I can do something like this, and which integers are achievable and which are not achievable. Okay, like for the first sample test case 1825 2, 1825 2, 1 is always achievable, 2 is also achievable, 8, from 8 can we get 3, 4 no, from 8 we cannot get 3, but from 25 can we get 3, from 25 can we get 3, 12 divided by 6, yes, from 25 we can get 3, so, and from 8 we can get 4. Okay, so if we greedily choose the smallest element from which we can get the particular number, I think this should work. I don't know, I'm not sure about this approach. And for this test case 2 1 1, for the test case it is not possible to do. Okay, now for test case, yep. So I think I should choose the smaller ones for the smaller numbers, cool, because for the bigger numbers other numbers will be there. For the test case 1 to 8 it should also be no. Now for the test case 24 7 16 7 7 7 16 24. Okay, so 1 can be obtained from 3 1 can be obtained from 7, 2 can be obtained from 7, can 2 be obtained from 7? How to do this? Okay, let's see how my friends learned it. Nope. None of my friends will not even know. So it's obviously a difficult problem. Okay, so how to solve for this test case? 24 7 16 7. Okay, so can 7, so from 24 how many numbers can I get? Okay, from 24, okay, so I think that all of these ranges should merge with each other, like okay, I think that I got idea. For 24 I will get a big range from 1 to n, then for this number I will get a range from 1 to n, and yep, so every number has to be visited once. Okay, and for 24, for the biggest number, which number should I assign it to? Okay, so firstly remove all the extra 2's which are present in that number. No, not that, like this thing, like for the test case. 6 4 6 22 22 22. From 4 I can get 1 2 4. Cool. Okay, so let's draw this like this: 1 2 3 4 5. From 4 I can get these two things. Okay, now from 4 I can get, now to get 4. Okay, and also I can get 4. Cool. Now for, okay, so now let's assume that, and now if any two numbers have a single combination only, if any two numbers have only a single type or coloring, I would say, or something else, I'm not sure about it. Okay, so how to solve this? 22 4 6 22 22 22. So 22 can be assigned to, okay, so the biggest number should be assigned to, okay, so if I could get n, I can get n by 2, n by 4, n by 6, and anything else. So the biggest number should be assigned to the so should I start from the biggest, or should I start from the smallest, or should I start from, okay, so 22 can be assigned to, can from 22 can we get 5? Yep. From 22 can we get 4? No. Okay, so now 5 4. Okay, now from 22 can we get 3? No. From 22 3 can we get from here. Okay, so I think if I could just readily choose the numbers from the smallest to the biggest, and if 3 can be achievable from a smaller number, it will also be achievable from a bigger number. So it is always advisable to choose the smaller number. That's it. So these observations should work according to me. Plus equals to 2. Okay, if oil current equal to I, found equal to 1. Okay, so if current equal to, okay, no, this should be current now equal to I, found equal to 1. Okay, cool. And okay, now slash equals to 2 or right shift. If found equals to 0. Okay, now if it is found, let's make it outside found only. Control V, if found. Okay, if found, and this of I equal to 1. Okay. Now if not found, answer equal to 0. Correct. If answer select yes selection else 0. No. Okay, so I think I should also sort these numbers. Okay. This is not like this. Sort method if current found equal to 1 break, we found V's of I equal to 1. If V's of I continue non-equal to S of I equal to 1, not considerable the frequencies of let's out not think this should work most probably. Control A, control C, control V. All lines are equal to 0. All lines are equal to 1. Okay. Yes, no, yes, no, no, no. Yes, no, yes, no, no, yes. Okay, so this one gives yes. Control C, control A, 1, 5, control V. For this test case for 1, okay, so I think I should go from the bigger to the smaller numbers. I think this should work. I think this strategy should work. Okay, and also I should go from the yes. For the bigger number, if I could get a smaller number, that's always yeah, this should work. Yes, no, yes, no, no, yes, yes, no, yes, no, no, yes. Let's check the code once again. Base of I continue, now this of I now current, and first one. Break is not found, this of I first one, break not found, control C. Submit this code once. C, control V, submit. Test 3. Cool. This one was a good problem actually. Cool problem. Problem C. Pinning here. What I just did was that I sorted it, and then for the bigger numbers, if I could get a smaller number, it is always good to have it is always good to have that. That was the critical observation here. Cool. Let's now move towards problem D. Yep. First line contains two integers. Contains two integers n and k. String as n and k, string as l. Let's first try to take the input and then see what we can do. Problem D is special from 97 people, so it should not be that much hard. You have a string is consisting of lowercase Latin letters. You have a string is consisting of lowercase. You can you have a string is consisting of lowercase Latin alphabet letters. You can color some letter in colors from 1 to k. It is not necessarily to paint all the letters, but for each color there must be a letter painted in that color. Then you can swap any two symbols painted in the same color as many times as you want. Cool. After that, k strings will be created. Ith of them will contain all the colors colored in the color I written in the order of the sequence in the strings. Cool, got it. Your task is to color the characters of the string so that all the resulting k strings are palindromes. Difficult problem. Cool. Difficult problem. How is problem E here? Okay, so C is also good problem since. Okay. Let's first play problem D. your task is to color the characters of the string so that all the resulting case strings are palindromes. Okay. Hmm. And the length of the shortest of these k palindromes is as large as mm, possible. Okay, so what the maximum length? Okay, I think this can be done using binary search since it is a min max problem. Can we do binary search here? And the length of the shortest of the string is as large as possible, so that all the resulting k strings are palindromes. Cool. Okay. Hmm. Length of the shortest of this k string is as large as possible, which basically means that, okay, so if I would choose a color, okay, you can also swap those colors. Swap into symbols painted in the same color as many times as you want. Okay, so if let's assume that I have painted indices x, y and z, then I can rearrange them in any way which I want. So it all boils down to something like this. I think the occurrence of each character will matter here. So I think the occurrence of each character will matter here. Let's see for this example. A B. Okay, so here A B X X Y Y Z. If I sort it, A B A B B X X Y Y Z. Okay, and I have to make two strings actually. So what we can do in this case is that so to paint the same colored strings, I could choose here. Can I make a string of length 3 here? Can I make a palindrome of length 3? I think 3 first case. So can I make a palindrome of 3? Yes, I can make A B A. This is one palindrome, and X X Z Y Y. This should be second palindrome. Or can I make anything else? Okay, so the character T. Okay, so for all of the k things, firstly I should try to choose the minimum possible that we can get. Okay, 2. Okay, so let's take another example. A. So in this case the answer will be 2. I think it's for dxd, the answer should be 1. Yes, AB. This is a good test given to me. A. Okay, so let's copy this and sort this. So S here A B B B C C C C A B B B C C C C. Okay, so firstly I will take these two A's. Okay, so firstly I will check how many A's are there. So A's, how many double characters are there. Okay, so I can make these characters A. Then we can make here A another double character. Then we can make another double character B, and then another double character C, and now remaining characters are B only. So we can make here 1 2 3 4 5. Okay, so 5 double characters are there. So I can include the 3 of them in one. A B in one, and sorry, okay, so I can include the CC, CCB, 5 in AA, AA, BB in the other. So this should be 6, I think, into 5. Okay, this will be 5. Yep. So I think the occurrence matters a lot. So how many submissions first? Let's see, 240 submissions. Easy problem though. Okay, so if I could get all the occurrences, that would be a great thing. How many twos can I take? 2 plus equal to h of I by 2. 2 plus equal to, and 1 also. 1 equal to 0. If 1 if h of I and 1 plus. Okay, so now in this one everything is good. Okay, dot 2 debug 1. Okay, so now using these many tools, how many characters? So can I just do a binary search here? Okay, so I can just do a binary search here. Just do this one. L plus 1 is equal to L plus R minus L by 2. Code x comma 2 comma 1 L equal to x else R equal to x C out L is less. L equals to 1 is always achievable and R equals to L minus 1 is never achievable. Good x. Okay, and also the case should matter. Okay, so no, the equation should be that there must be. Okay, so I think one search here 2 1 LL length basically, and the answer now LL 2, the 2 ones, LL 1s and LL k. So these many ones are always there. Okay. Now one thing is that if 1 is greater than k, this means that if 1 is greater than k, this means that ABCD. This means that I cannot color if 1 is greater than k. Can the answer be 0? K is less than m. Okay, so if 1 is greater than k, let's assume that ABCD and k is 2. Then how will I set those characters? First test case BX1 AB A XY by Z. Okay, so if there is ABCD and the number of characters is 2. So there is ABCD. Okay, ABCD 1 1 1 1 and the number of characters is 2. Yeah, okay. If 1 greater than k, if 1 is greater than k, the next one should be 0. If 1 greater than k, okay, so 1 can be up to 26. Okay, if 1 greater than k, C out 0. C out 0, I think, because like if the example is A B C D and the value of k is 2 only, so A B C D need at least 4 characters. So 1 always has to be less than equals to k. Continue. Always has to be less than equals to k. 2 1 comma k. Okay, that equals to x. Okay, so the minimum number of characters. Okay, so the minimum length that we can get is already the number of ones. the number of ones. Okay, and so the maximum length which I can get, so the minimum length which I can get is already once only, and now the maximum length. So now after I got once, I will assign all the other remaining characters 1 minus k characters equally firstly 2 करके मैं असाइन कर दूँगा. ऐसा वाइस करने की ज़रूरत नहीं है शायद, और क्या ज़रूरत है क्या, ज़रूरत नहीं है शायद. Case here 0. Okay, so answer is 2 already equal to 1. Okay, now extra equals to, I think should be 1 minus k. Okay, 1 sorry, it should be k minus 1. Okay, so k extra, so 2 parallel x equals to minimum of the number of same characters and extra. Okay, the minimum of the number of same characters and extra equal yeah, okay, 2 minus equal to x, extra minus equal to x. Okay, 2 minus equals to x, 2 minus equal to x, yeah, full, and also extra, that is the remaining characters, minus equal to x. Okay, now can I assign k minus x, k minus 1 actually. Okay, so if I am able to assign each of these characters at least 1. Okay, if extra, now if I cannot assign at least 2 characters to each of them, then the answer is one's lesson is, now I have some extra 2 characters with me, and I can and ones equal to answer equal to, okay, so now some ones and twos are there. Okay, so I should okay, like there are a b b c c, and now I have c c c c d d d d. So I should assign the firstly the characters. Okay, so I think I should just take out the minimum element and assign some values. Okay, priority queue, priority queue, priority queue relates to priority queue comparator, priority queue l factor of l, compare struct compare node start a return. aliases. We can call Z equal to 3301 something that is happening here. 0. Okay, so which case is giving 0? Okay, so what case string? Okay, for 30 you can color any character and take it into a string. Okay, it is not necessary to paint all the letters. Cool. Okay, so I think this is not necessary actually. Okay, 2 plus equals to 1 plus. Okay, so this whole thing was wrong actually. Shit. Let's iterate over the answer equal to always 1. Then answer equal to 2, answer less than equals to 1, answer plus false. If I equal to answer I equal to 2, current equal to 2, current less than equals to 10, current plus select answer. Okay, so then required, so the required ones, the if 2. Okay, so if the, so now this is the required length. Okay, so since if the required length is odd, okay, so since the required length is odd up to k strings. Okay, so k into required number of characters. No element such that, okay, if current and 1, okay, else, okay, 1 equal to 0, 2 equal to 2, so here is 2, here is 1, okay, 1 equal to k, okay, current and 1, okay, if current and 1, okay, if it is current and 1, then there should be some middle character also. Okay, and the extra should be something less. Okay, got it. If current and 1, cool. Okay, let's first solve for the even case. Now if current is even, then in that case all the characters should be same. If current into k less than equals to 2 into 2, answer equal to current. Okay, and then in the case of odd case, the minimum required is equal to minimum of k comma 1 equal to 1, minimum 1. Okay, then x equal to minimum of k. Minimum of k1 comma 1, k1 minus equal to x, k1 minus equal to x. Okay, so now 2 plus equals to 2 plus equal to into equal to 2, I think, maybe equal to 2, yeah, okay, so k1 minus equal to x, k1 minus equal to x, okay, 1 minus equal to x, okay, yeah, now let x equal to minimum of 2 1, 2 equal to 2, minimum of 2 1 comma k1 minus equal to x, 2 1 minus equal to x. If current by 2, if current minus 1 into k less than equals to 2, answer equal to current. Okay, I think these things should work. Control V, Control V. Okay, then x equal to minimum of k1 comma 1 1. What is here? X equal to 2. 3311511133 3311511133. Okay, control C, submit code. I wasted a lot of time in probability here. Okay, so wrong test one, that's bad. Second number different, found 2, expected 2, found 3. Okay, so for second test case. Okay, what is important? Second test case, control C. One, control V. 3, at least 3 numbers should be there. Okay, expected 2. How will 3 characters be there here? 1 plus plus. Okay, k1 minus equal to x, 2 1 1 minus equal to x. Okay, if current and 1, if current into k, current into k, 2. Okay, if current equal to 3, current equal to 3, plus equal to 3, plus plus 3. Okay, so 1 1 is 1, 2 1 is 2. Okay, k1 equal to k. Okay, now how many I have assigned? I have assigned x equal to minimum of k1 comma 1 1, k1 minus equal to x equal to minimum of 2 1 comma k1, debug cout debug k1 okay, so k1 debug k1 debug 1 1 debug k1, just debug k1. Okay, x debug k1 is 3 yes. Okay, so minimum of, okay, this is bad. Okay, this is not bad. Okay, now x equal to minimum of 2 1 comma k1, 2 1 comma k1, k1 minus equal to x, 2 1 minus equal to x. Okay, now if k1 is present there, okay. Okay, now if 2 1 is less than k1, 2 1 must be 2 1 minus equal to k1. If current minus 1 into, if current minus 1 less than equal to 2, it's equal to current is equal to 2 1 3. How is it 3 bro? 2 1. How many 2's are now remaining? 2 1 3, only 3 2's are now remaining. Now current minus 1. Okay, so I think I've done some mistakes here. No, okay, so current minus 1, okay, into k I think. Cool. Current minus 1 into k, I think. Yep. Control V. 3 2 1 1 1 5 1 1 3 3 2 1 1 5 1 1 3 3. I think this is correct. 2 plus equals to h, plus equals to 2, plus equals to answer equal to 1, 2 equal to 2. Okay, cool. What if 1 1 equals to 1, 2 1 is k1, x equal to minimum of k1 comma 1 1. That's great. K1 should be minus equals to x. Yep, that is it. If the number represent 2 must be 2 will be k1. This is correct. Submit code. Let's get it here. Test 2, test 17. Okay, happy new year, cool standings. I have 24 minutes there. You must be pretty fast here. I wasted a lot of time. Problem D. No problem. Let's now move towards problem. I should do G or among E or F. Let's first go towards G. Recently, that has been carried away by Spanish restaurant to give you the. Let's first go towards the bathroom. I think OBS is recording here. OBS is recording here. Yeah, 51 minutes past. Which problem everyone is doing here now? Understanding school 1.1 mistake around test 2. That's bad. So I think G is the ideal option here. That has been carried out by spanning tree, so his friends without hesitation gave him a connected, weighted, undated graph of n vertices and m edges. Blad defined the ority of a spanning tree as the bitwise OR of all of its weight. In what is the minimum possible ority that can be achieved by choosing a certain spanning tree? A spanning tree is a so it's minimum possible thing which should be achieved. Okay. So is this easy problem? I cannot see about it. I did this for faltu reasons. I don't think G is an easy problem. Let's first move towards E. Masa meets a new friend and learns his phone number as she wants to remember it as soon as possible. The phone number is a string of length m that consists of digits from 0 to 9. The phone number must miss E and how is following F here. Okay, so F is an interactive, so I am not going to do F now, either E or G. Let's first go towards E. Let's see what the problem is. Must already knows n phone m. It will be easier for her to remember a new number if S is represented as segments of numbers she already knows. Each segment must be of length at least 2, otherwise there will be too many segments and confused. For example, Masa needs to remember 7 phone numbers 1, 2, 3, 4. As a 3 segment 1, 2, 3, 4 of number 1. Okay. Raise into segments of length 2 or more numbers. If there are 7 answers, print any of them. Okay, got it. Let's first go with G only. G seems easier. I'm not able to look at any ideas here. G seems easier. Recipe. G here. Let's go on G first. So his friend is connected weighted undated profile but temperature as the bitwise OR. Bitwise OR of all of its ways. Okay, shit. So bitwise OR. So I think this is easy. Since it is bitwise OR, okay. So I should first check if I can do it. If I can exclude the bit, if I can exclude the bit number this thing or not. And what are the weights? Okay. Okay, okay. So firstly, what I will do is that I will firstly check which edges contain this weight. So if I can achieve this, and then it is okay. Otherwise, I should take all of those weights. Okay, so I think this problem can be solved using this greedy strategy only. Like for every bit I will check if I can solve the problem excluding this bit. If I can solve the problem excluding this bit, then I will not include any of those edges that contain that bit. Okay, yes. And if I cannot solve the problem, then I will include all of those edges. Greedy strategy. Just I have to do some Kruskal algorithm. Okay, easy problem. Easy. LLMM sin n factor of g of n plus 1 parallel to 0 percent okay, so it should be like a pair only, pi pi only, uvw I think. Okay, lel uvw c uvw parallel to 0. Okay, so what I'm doing here, g of u dot pushback v comma w, g of u dot pushback u comma w. Okay, for alpha to 0 I less than n. Okay, okay, so no, that's not actually this much of easy. Yeah, okay, so okay, minimum possible spanning tree. Easy according to me. Let's try to solve this, bro. Yep. So which edges to include? Okay, so 30 edges, 30 bits are there. Okay, so I have to form a connected component. Okay, and now if I cannot achieve these things, then I should include this bit. I think so. I should include this bit, minimum bitwise or itself. Itself is as more specific, and minimum bitwise or itself. Okay. So firstly for the largest bit, if we can exclude the largest bit, then we must exclude the largest bit. Okay, now if we need to, okay, so this is going a little bit difficult. Connected component, so it's a single connected component only. Standings d was easy. Yep, d g spanning trees are this other. You want to keep n minus 1 so that the, okay, so in this case, okay, so in this case I cannot keep it. Okay, so I will already have some edges added to my thing. Okay, and okay, so there will be some edges which I must add. Okay, so there are some edges which there is a concept called critical and pseudo critical edges. There is a lead code problem, I think, according to me. Yep. So if I could find the number of, okay, no, that's better. I think problem E will be much easier for me. I'm not good at graphs. So probably let's start with E first. Mathematics and if and see first let may imagine I containing integers n and m. The number a phone number that must have each phone number. इसका number basically known as the phone number of a new friend is. There must be there may be duplicates, identical phones. Okay. So for the first test case, there are 8 questions that I attempt here. This seems difficult for me, but it also is the minimum possible already that I can should mention. So if this particular weight, so this particular age cannot be excluded. Critical and pseudo-critical ages. Critical and pseudo-critical ages. Decode. I solved this problem previously. Let's go to my solution. This is similar to this problem, I think. Discuss section submission. My submission used what I did a O of n or O of m square thing. The problem can be solved in O of, that is constant is small here. Okay. So what I did was that critical x, okay, x equal to 1, okay, critical x equal to 0. Okay, so what did I did here? What is the time complexity of my solution here? Finding this critical pseudo-critical ages. Let's find some define shit here. Critical age, an age belongs to all the MST of a graph. Cool. An age belongs to at least one MST of a graph. Find any MST and the corresponding MST weight. Cool. Okay, so I think it can, okay, so it's an MST problem. Cool. Okay, so now let's find the MST here. Okay, so let's firstly find the MST here. Okay, so MST is the bitwise OR only. Bitwise OR. Does bitwise OR has similar properties with bitwise and or with the summation? I don't think so. The problem will be easier. What is problem E here? First line contains in and m the number of phone numbers then that Masa knows and the number of digits in each phone number. Okay, so Masa knows this much of phone numbers 1, 2, 3, 4, okay, and the last number and in lines as well. Next line contains the phone number of a new friend S, and this age has the same length. Cool. 1, 2, 3, 4. Okay, so fine. Okay. So I think I can do some sort of a dynamic programming, some type stuff here. Like 1, 2, 3, 4 for the first test case. 1, 2, 3, 4, 0, 2, 1, 9, 2, 0, 2, 1, 5, 6, 0, 1, 5, 6, 7, 8, 2, 0, 2, 2, 1, 2, 3, 0, 0, 6, 7, 8. Just a second. It will be about if as a sum says each segment must be length to many segments and one fewest. Okay. number s equals to number of s. Okay. The number s equals to 1 2 3 4 7 8 9 10 numbers. 3 segments 1 2 3 4 of number 1, 5 6 of number 2. Okay. So finding a segment, so finding if the segment is so if I can do something. Okay, 7 8. Okay, 1 2 3 4. Okay, so can there be same segments? In the third test case, you can select segments 1 2 and 2 1. Third test case, what is the third test case? 1 2. Yep. Okay, so I can choose 1 2 and 2 1. Okay, so I can choose the same element also. I think there are some notes here. So I can do something like a KMB to find the string matching part, and for the other parts I can do just run a simple DP solution. That would be fine. Yeah, that's it. Yeah, okay. So E. Okay. First one contains the number of test cases. Then the second contain integers m and n. M contains same m, factor of string a of n, and also there should be string s. And the length of string s can be anything. This is of length n. Okay, so it's also length for index same x. Okay. So can I do a TP type thing here, like if this particular segment is present or not, of length 2 or more. Okay, number of digits in each phone number. Okay. Like here I can search for the number 2 1. Okay, I can just search for the number 2 1. Okay, and this thing I have to search here, so it will be of n square actually. And now can I keep all the segments in a set? Can I keep? Okay, so there will be n square segments for each one of these numbers. There will be n square segments for each one of these numbers. So I cannot keep all of these segments. Okay. Check this thing of this thing. G is difficult. The problems are pretty interesting, but I'm not able to solve them. Okay, each the same as another will be 2 many segments. Okay, so firstly let's assume that. Okay, so TP of m. So what I can actually do is that I can check for only the segments present in S, present in M. Okay, and the number of such segments will be O of n square segments. Okay, and to check them, of n square segments. Okay, and to check them requires time limit is 3 seconds, and to check them for each one of the m numbers. It takes a lot of time. Okay. Okay, so let's assume that I can form this string. Okay, so can I do for the segments of length? Okay, okay, just one thing to check here. If I can get a segment of length 3 actually, if I can get a segment of length 5 from anything, then I can get a segment of length 1, 2 and things like that. Okay, so okay, so I have to only check segments of length 3 and 2. I think that should be it. Yep, that should be it, because let's assume that I took a segment of length 5. In this 5 length segment, if it is even, can be broken into segments of length 2 each, and if it is odd, then all segments 2 and one segment 3, it can be broken. So I have to only consider check segments of length 2 and 3 in my array. Cool. This will be here. So this will be here, and this check function will be n square. Okay, dp of n, return. Can also print the numbers, I think. From number get or number segment initial place numbers. If answer is yes, then follow again returning triple sound is flat. Such means that next armors or digits of number s are equal to segments of the string with boundaries m to more phone number under I. Cool. Okay. So I have to keep TP will keep track of the previous number also. Keep track the previous number. Okay. Firstly, let's of map of string for 0 and less than plus for j equal to I plus 1, j less than for ln alien equal to 0 for ln j equal to I plus 1, j less than equals to I plus 2. Yes, only I plus 1 and I plus 2. J plus. Let me check this much segments. Ln current equal to, okay, and equal to J of for ln, okay, for ln current equal to S of I. Okay, and now this check can be performed in O of n. Ln current equal to S of I. Okay, now current is equal to S of J. If possible current S. Okay, now for ln j equal to 0, and this all of this will take a time complexity of n. Okay, so I think it's again n cube n into n cases. Nope. Segments of length 2 and length 3. So this will contain n segments, n square segments only. Okay, got it. Map of string np to 0. Let's get it like this. this is open squat. Control V. Okay, current plus equal to, okay, current plus equal to s of j, current plus equal to s of k. NP of current equal to I. Okay. dp vector of vector of pole, vector of LL, dp of for the alpha 0 minus n plus for j equal to 0, j less than n, j equals to, okay, so if I can reverse this thing, okay, so this reverse operation will also be of O of n or O of 1 if I just reverse my string. Okay, so or I can do something like this. I will do from the back end. I equals to n minus 1, I then equals to 0, I then equals to 0, comma I minus minus current equal to s of I, and then j equal to I plus 1, j less than n. Okay. J equal to I plus 1, j less than n, j plus plus current plus equal to j equal to I, j less than n, comma j plus plus. Okay. Current plus equal to s of j, expression of current and then I less than n minus 1 with the if and dp of I plus 1 is 1. Okay, and if this thing happens, then in that case dp of I equal to the next character. Firstly, let's easily convert them to minus 1, and then okay, so the next character. Okay, dp of I minus 1, dp of I minus 1 not equal to minus 1, I plus 1 not equals to dp of j less than n minus 1, and then dp of j plus 1 not equals to minus 1 and so on. That is 1. dp of I equals to j plus 1, the next character. Okay, cool. J plus 1 correct. If dp of 0 equal to minus 1, okay, so minus 1 slash n, okay, see out k. Okay, now just a vector of LL, answer vector of PIL, answer. Okay, current equal to 0, current equal to 0, while current less than n. Okay, for I equal to current, I less than dp of current plus plus string now. This is a O of anything plus equal to s of I. Now plus equals to s of I. Okay, and plus equal to s of I. Answer dot pushback. Okay, answer dot pushback I should keep L and R. Okay, should keep L and R the boundaries of the phone number under I. L and R. Okay, not good. If current plus I. Okay. NP of current. Okay. Set of P of I is NP of K of I equals to J comma K. NP dot current. NP of current equals to J from index J till index K. and of the element, okay, and of the element I also, okay, LP of element j k I. I think I can keep a pair here only. Okay, j k comma I. Yeah, it's the length r minus digits j and jk from j till k, and the index is I cool. Okay, now if present of current, this is in present of current, okay, if okay, let's keep it separate, okay. So IT equals to np dot find s of j. To j plus 1 break, okay, cool, j plus 1 break, cool. The file is minus 1, okay, the should equal to minus 1, now plus equal to addition dp of current, my plus now plus equal to and some dot pushback mp of s, okay, see how LNR should be, I think, L and R, okay, LNR should be, I think, plus 1, I think should be there. For the file, let's solve for a small test case first. This should be present of now plus equals to s of I. Now plus equals to s of I. I have not taken s, I think. Same as IT equals to np dot find. IT equals to present dot find. Present of now. What is present PRE is EMT. I can do something wrong down here. So push back. Type write what around current plus equals to s of j. Current plus equals to, okay. Some wrong. What is wrong here? What thing is wrong? Auto IT present dot find s of j. Present dot find not s of j, be current. Okay, so the sum test cases is there 2, 3, minus 1. Second test case answer is minus 1. Let's solve for the third test case. Control C, Control V. So it's even sign minus 1, okay. Let's try to dp. Okay, so for dp, okay, dp of flame should be m only, okay. I equals to m minus 1. It's wrong here. dp should be of length m. Okay, less than equals to j plus 2, k less than equals to minimum of m minus 1 and j plus 2. dp minus 1 minus 1 minus 1. Okay, dp of 0, dp of 2 1. Present of 2 1 of 2 1, I think 2 1 slash 7. This thing should be there. B present of 2 1 slash 7. C out. Okay, got it. Present of 2 1. Again around what I'm doing here though. Present wrap up string, I think. Okay. So 2 3 0 1 2 3 2 3 and the index is 0 1 2 3. Why is it 2 3, bro? 2 3 j to k is to I one thing just here to 0 2 3. And why is it 1, bro? Okay, yes, it is 1. J equals to 0, j less than m, j plus plus current plus equals to, okay, this will be s of j, a of I j, f I j, a of I k, 1 to 0, 1 to, and it should be 1. Cool. Present of 2 1. This is cool, I think now. dp. Okay. Is the answer showing anything? Okay, debug dp. Again it is showing minus 1. Current plus equal to s of j. Okay. If n equal to if I equal to 2. Less than m minus 1, this should be. M minus 1, bro. Minus 1 is still minus 1, bro. Okay. If I equal to okay, if I equal to 0 1 2 and then j equal to 1 here and j equal to 0 1 0 1 2 3 okay. See out current. Okay, current if I equal to 2 and then j equal to 3 current plus equal to okay, got it. This one was bad there. 21 cool. dp 2 minus 1 4 minus 1. Okay, so this is actually happening something there. What is happening there? I think I have to restart my program here. Restart my test case here. Let's try this. Let's multiply all of these things. Okay, so compiled. While current less than, there should be n. While current less than n, and then this should work out. This is not good. Dp of 0. Okay. current equals to dp of current. Okay, current equals to dp of now equals to dp of current equals to dp of current. That's it. 2 1 2 2 1 2 1 1 2 1 and 2 of 1 2 and 3 of 1 2 1 2 1 2 3 1. I think this is now working fine. 4 4 4 1 2 4 4 1 2 4 1 2 of 4. Okay, 1 2 4 3 4 of 1. Cool. 5 6 of 3 and 7 8 of 4. Cool. Second test case answer is -1. That's it. Okay, test case -1. Third test case answer is 2 1 2 1. Fourth test case answer is 3 3 1 3 2 5 6 3 3 4 1. That's working fine for the sample test cases. Submit. Let us check it. Okay, cool. Yes, let's get it bro. Okay, so now if I could solve G, I would be in a pretty good position. I need to solve G now. Okay, G now. Okay,
শেষ জল আছে তো?
okay, now to solve problem G. Okay, problem G. G here. What is problem G here? D and test case. This is an easy problem, I think, but I'm not able to solve it. I'm bad at graphs. I think OPC is recording. Yep. G of n plus 1 G. Lot of solutions in problem G, bro. First, let's go to the bathroom. Okay, we are back again, and now we have to get G. 40 minutes remaining. Okay, Priyan's also solved G, so we'll be in a pretty good position right now. He also solved E. Okay, let's solve it. E. Beto's blood has been carried away by spanning trees, so his friend, without hesitation, gave him a connected weighted undertaker graph of n vertices and images for his birthday. We define the ority of a spanning tree as the bitwise or of all of its weights, and now he is interested in is what is the minimum possible ority that can be achieved by choosing a certain spanning tree. Okay, how to solve a genome? Okay. Minimum possible spanning tree. Okay, so what will be the minimum possible? So if I would just find the minimum spanning tree. So while finding the minimum spanning tree, okay. So if an edge comes, I will not take that edge. Firstly, draw a tree from the spanning tree. Okay. So if I first draw a tree from this graph, minimum spanning tree from this graph. Okay. Now I have to include in let's rotate a node 1. Vlad has been carried away by spanning tree, so his friends without hesitation gave him a connected weighted undertaker graph of n vertices and n images for his birthday. Vlad defined the ority of a spanning tree as the bitwise or of all of its weights, and now he is interested in what is the minimum possible ority that we can by using a certain spanning tree. Okay. So which bits to consider? So I will first try to do which edges are part of all of the spanning trees. Okay, and I think that finding critical edges part is easy. Yeah, finding critical edges part is easy. Because summations. Yeah. Okay, finding critical edges. It is not true. It is a problem. I'm going to get problem in G here. As the bitwise or of all of its weight, now interesting. What is the minimum possible quantity that can be achieved by using a certain spanning tree? Spanning tree is a connected subgroup. Okay, so how to get this? Okay, so if we can choose it. Okay, so if we can do that. Okay, so if we can, so I can check for each and every bit. If by removing all of the edges, can we still connect this graph? Yep. Firstly, I will check for the largest bit. Okay, so if I can connect those edges, then this largest bit is already included in my set. Okay, got it. I think I could solve this problem. I think I need to keep the edges here. Okay, so let's clearly state what we are going to do. Firstly, for the largest bit, let's write it here. For the largest bit, check which edges contain that. If by removing all those edges strategy will work. How many time is left? 35 minutes left. Minimum spanning tree. Okay, so this is not millimeter, so let's first less than 31, I think. 1 is to 9. 2 is to 30 will be better. Less than 30 plus. Let's go from the largest towards the smallest bit. So I should just add those bits and and those x, and I have to keep track of the excluded bit also. Excluded m, now this of m. Plus if edges of I dot sc and 1 else left bit. This means that this bit is present here, then this of this edge should be equal to 1. Okay, now what I need to do is that I just need to check if all of these can be connected or not. If connected, this excluded. Okay, if connected. Okay, so all the edges which are being removed from excluded and all the edges from this, if all of them are removed, if connected this comma excluded comma okay, if connected this comma excluded, excluded m is cool here now, and m is less bit. If edges of I dot sc and edges of I equal to 1, what is edges? Edges of I dot f I dot sc, edges of I dot sc, edges of I dot sc, and 1 is less bit. What is wrong here? Don't know. Check it later. Okay, so now excluded, and also I think you should do n also. And n. Let's construct the graph and this is g of n plus because of bool resident of n plus 1 for n equal to 0, g of I dot pushback, g of edges of I dot fi dot pushback edges of I dot sc, edges of I dot fi dot sc, fi dot fi pushback. Now g of edges of I dot fi dot sc dot pushback edges of I dot s dot fi dot fi. dfs 1, 0, g, dfs 1, 0, g, visited equals to 1, equals to n, plus plus if not of visited I and 0 and 1. Cool. dfs alignment G factor of pool and face of node equals to 1 if face of node face if visited of node visited of node equal to 1 for author and child g of node dfs child munchie face visited okay visited. Cool. How much time left? Time left is cool. Okay, control C. First dfs this would be return actually, return here and visited of I, control C, control V. Something is wrong here. Long if constant edges of I dot sc, edges of I dot sc. Okay, pair I have not defined pair. Got it. Here comma here. Now should define I less than m. Okay. m okay, if exclude if place of I, face of I excluding I all equal to this I, control B. Something wrong again. Excluded, if not a ratio and not of excluded. Excluded I. Excluded I. Okay, I cannot do this thing. Let's just do this like this. If is excluded of I equal to 1. Okay, so okay. Okay, somewhat I have not mentioned in 0 I think. Okay, but also other problems are there like base of I. Okay, I think I can only do the base of excluded of I equal to 1. I can also do excluded only. So let's see. If not of excluded I, base of I equal to 1. Okay. The n comma face face comma edges n comma face comma edges. Cool. That's a bad answer, bro. That's a bad result, bro. Okay. Content, okay. Okay. It's not equal to 0. Okay. Connecting. हो सकता है bro. Okay. 30. Okay. Connected. Okay, so the bits which are present here, I have to check all those bits. Bit only one is present here. Okay, so bit hs of .sc and 1 // bit sc and 1 // bit. Okay, hs of .sc .sc. Okay, cool. Slotted by separation equal to 1. Debug bit. Okay, so for 1 0 2. Okay, now so I can only exclude the bit 1 and I have to include all the other bits. Okay, so I can face of I equal to 1. Okay, so if okay, got it. If not, if excluded I, okay, so I think that would be much better. So if I equal to 1, I have to exclude all those things as well as those things that are excluded. Okay, this comma exclude. Answer is 2 here. 2 here. Cool. Let's check for our cost also. Control B. 2 10 3. Okay, it's getting the correct answer. Okay, yes, and this thing is cool. Is of n is of I equal to 1. Now if ages of I.sc, that is ages of I equal to 1. If it is connected without these things, exclude I equal to 1, else I have to input those things. Okay. If it is connected without these things, excluded I if using 1 0. C. Control B. 2 10 3 is the correct answer. So it's not the cases. Submit code. Control G, Control V, submit. Check now. Test 3 46. Cool. Happy New Year. Cool. What is the time limit for this problem? 2 seconds, and my running time is pretty close. So this time can my solution get hacked here? I think I must try to optimize it a little bit. What is the running time of other participants here? Other participants here. Priyan's running time. Okay, so I must go to participants here. Submissions. 545 milliseconds. Mine is pretty huge. I don't know why is it that much. It might fail just other cases. Try to or let's try to first optimize G a little bit. So okay, so which areas can I can include? Okay. Okay, I don't think there's no need to optimize this thing. This thing will be okay, I think, because my running time is actually 30 into O of n plus m. 36 into 10 raised to the 7 is okay according to me. This makes sense. Cool. So let's see and try problem F. Last remaining problem. What is my current rank now? Standings. Current rank now. Current rank is 80. Cool rank, bro. Interactive problem F. The problem is interactive. We decided to play a game with you, or should I try to solve G here? See, for G here, can it be optimized here? I cannot optimize anything here. Graph should be formed every time. I could have optimized those edges, but I think that it will pass the cases. I think so. कुछ certain that verifying was from all of them. We don't want any further. If optimistic, but okay. Problem E was also a good problem. 50 milliseconds. If we decided to play a game with you and guess the number x where you know the number m. You can make queries like this: plus c, this common assign x equal to x plus c and returns you the value floor of x by n, x divide by n and round down. You win if you guess the current number with no more than 10 queries. Okay, only 10 queries. I think binary search can be done log base to 1000. What is the value? Log base to 1000. Log base to 1000. Code will be 1000 is 10. Okay, so it's something like a binary search only. How many minutes left? Only 60 minutes left. My submissions are cool. Okay. Look at the full F here. Interactive problem. We decided to play a game with you and guess the number x where you know the number m. You can make queries like this: plus c, this command assigns x equal to x plus c and then returns you the value x by n, x divided by n and round down. You can guess the current number with more than 10 queries. To make a query, print on a several name plus this command will query. Okay, so what I can do is that how to solve this problem actually. So what I can do is that x equals to x plus c okay, by n. Okay, so can I just do it by x plus n minus 1? Is it possible to do? I I think it is impossible to, it's not impossible, but it is very difficult to do with such less number of plus 152 plus 140 plus 35 to expert plus 152 cool plus 80. I think I should check my solutions again. Let's try this once. Plus this command assigns x equal to x plus c, x equals to x plus c, and returns you the value x plus c by n. Okay, so let's, okay, okay, so and the number is also less than n only. Okay, so firstly, if I can do a mid type thing, I think I can do such type of a binary search type thing. Like I would check for, let's assume that n is 100, so I'll check for 50. If x plus 50 by n, okay, so what equals to something, okay, so x plus 50 greater than equals to the quotient which I would get answer into n. So x greater than equals to answer into n by 50, so into n by 50, and x less than equals to something also I will get, and x less than equals to, okay, so I will get some ranges here. Okay, so firstly, okay, so this problem is easily solvable according to me. X z question mark z plus c plus c plus x answer, same answer, return answer, cool. Okay, so now, okay, okay, so now everything will lie in this range only, r equals to 1000. Okay, so how I have to check for if it lies in this range or not. L equals to 1, r equals to n, while l plus 1 while l less than equals to 5. Okay, see that, okay, l x equal to l plus r minus l by 2. Okay, if l comma if code n comma x over n, okay, so if it is present in this range, so then r will be equal to n comma x minus 1 comma n, r will be equal to x minus 1, else l will be equal to will be equal to x minus 1, sorry, r will be equal to, okay, so if it is present in this range, then a will be equal to x, else sorry, r will be equal to x, else a will be equal to x plus 1. Now, and now in the case when both a will be equal to r, I will just print this out a and l. I think this is it. So only 10 minutes remaining. Submitted this. How do we? No. This is doable. This is doable. This is doable. F interactive problem. Okay. x by n. Okay, so if good L comma x comma n are equals to x, okay, now to check L comma L r comma L n. How can I check if it lies in this range or not? Okay, so this quotient L, so this quotient, okay, so 2 into L, so 2 into L, so let's so x plus c by n greater than equals to L. Okay, so x plus c by n greater than equals to n. So okay, x plus c greater than equals to n into L less than equals to, okay, and let's see, but it would be done by binary search according to me. So I think that this problem cannot be solved by me in this small 8 minutes of, with only 8 minutes time left. So I just quit the contest by seeing my rank for 8 minutes left. 107 rank, cool rank, expert level performance by me, cool. So thank you guys for watching my video. See you in the upcoming contest.